All right, we're working on FreeFall practice worksheet. We're on number 4. We have a college student who wants to toss textbooks to his roommate who is leaning out a window directly above him. He throws the book upwards with an initial velocity of 8 meters per second. The roommate catches it while it's traveling at 3 meters per second. All right, so let's kind of draw our scenario here. We got one guy standing down here on the ground. We got another guy leaning out the window up here. He's going to launch a book up in the air. As it's traveling up through the air, it started at an initial velocity of 8 meters per second. When it got to the roommate, it had a velocity equal to 3 meters per second. Part A says how long was the book in the air, so my time is my unknown. And because we're next to the Earth and we're in free fall, we have a projectile. We know that the acceleration is the acceleration due to gravity g, which is a negative because it goes down 9.8 meters per second squared. And now, since it's looking for how long, we have an equation from our equation sheet that says final velocity equals initial velocity plus acceleration times time. Remember, we're going to call acceleration g. We're going to rearrange this to solve for t, so we're going to subtract the vi, so vf minus vi gets rid of that. We're going to then divide by g to get on this side, and that's all equal to time. Final velocity was 3 meters per second. We're going to subtract the initial velocity of 8. We're going to divide all that by the acceleration due to gravity, 9.8. And we solve all that stuff. We don't have such a glare on it. We have 3 minus 8 divided by negative 9.8. We get our time of 0.51 seconds. Okay, we're on to part B. How far vertically did the book travel? So from here to here, how far has it gone? So really, what's my change in position? Since my initial position, we're going to count this as 0 right here. If that's 0, then my final position and my delta y are the same thing. So we don't have to break that apart. We have an equation that says delta y is equal to VIT plus 1/2 acceleration, which we call g, t squared. Now I can use this equation now because I just solved for t, okay? And I have initial velocity and I have acceleration. So if I plug my numbers into that, my initial velocity was 8 meters per second. My time that I solved for was 0.51 seconds. We're going to add that to the 1/2 times the negative 9.8 meters per second squared times my time of 0.51 seconds squared. Okay, let's put all that in the super duper calculator. 8 times 0.51 plus 0.5, because that's 1/2, times negative 9.8 times 0.51 squared. And we do all that, we get 2.8. That's enough decimal points for us. 2.8 meters. Okay, easy enough, and we had time. But if we look at this, originally we didn't have time, we just had these 3 variables. What if we don't want to do part A? What if we just want to solve for how far it went without having to solve for the time? Because maybe that's all we're asking about is how far. We also have an equation that says final velocity squared equals initial velocity squared plus 2 times acceleration times the change in position. No time involved. And so we can solve for this delta y because we have these other 3 items without ever solving for time. Let's see if we use that equation if we get the same answer. So let's solve for my delta y. So we're going to subtract the vi. So vf squared minus vi squared. That gets rid of it off this side. Then we're going to divide by the 2g. Right? So divide by the 2g. And that gives me my delta y. So let's plug those in. Final velocity was 3. So 3 meters per second squared minus the initial velocity of 8 meters per second squared divided by my 2, forgot about the 2, times my acceleration, which is negative 9.8 meters per second squared. You notice I have meters per second, they're both squared on the top. So I'm going to get rid of my second squared, and I'm going to have just 1 meter left over, which is what I want. So I'm doing good so far. Let's see if I can put it in my calculator and still do good here. So we have 3 squared minus 8 squared. Oh, what did I hit there? Well, I did a log. Who knows what I did? Let's try that again. 3 squared minus 8 squared That looks better. Divided by 2 times negative 9.8. And we get 2.8. Look at that. What were we supposed to get? 2.8. So it worked out. Didn't matter which way I did it, which is great. Right? It's like magic. So let's go to part C. Part says to redo the problem and have the roommate catch the book as it's traveling down. What are now the time and displacement? So we're going to redo the same thing, but this time, maybe he didn't catch the book as it went by, and so it kept going. But pretty soon, gravity's going to take, not let it go any higher, and it's going to come back. So he's got another chance to catch it. So we caught it coming back this way. So now my velocity final is not that, but it's negative 3 meters per second. Okay? So let's see if we can solve this guy. So my time, we can use the same equation. It said time is equal to velocity final minus velocity initial all over my acceleration due to gravity. And so now my final velocity is negative 3 meters per second. My initial velocity is 8 meters per second. He's still a positive. It's minus a positive all over the negative 9.8 meters per second squared. So again, put all that in our calculator. Negative 3 minus 8. Now we get negative 11. Divide that by negative 9.8. And we get 1.12 seconds. And that makes sense that it took longer to go because it went that 0.51 seconds to here, then it had to come up and go back down to where he caught it again. So it makes sense that the time was more. Well, let's look at this one. So we'll do the same thing. Delta y is VIT plus 1/2. We're doing a G, I get so used to the A. Squared, plug our numbers in. My initial velocity is still 8 meters per second. Okay, my time is now 1.12 seconds plus my 0.5, right, times my negative 9.8 meters per second squared times my 1.12 seconds squared. Okay, my time is squared. So let's plug all that into the calculator. Sorry, 8 times 1.12 plus 0.5 times negative 9.8 times 1.12 squared. And we get 2.8 again. It's like, wow, now that's real magic there. How did that work? That was amazing. We went all the way up here and all the way back down. So remember, the distance changed, but the displacement, we're still going from him to him. So my displacement is still this section in here. So it should be the same number. There was extra time, but because of these, we're counting this going up, and then this is kind of pulling me down, so it changes. And it actually figures out in the equation how all that works. It's kind of amazing and kind of like magic. We could put it in this again, but you notice with this one, it changed to negative 3. Well, negative 3 squared is still the 9, right? So the 9 minus the 64, we're still going to get negative 55, and we're still going to get the exact same number if we do it that way. So feel free to try it on your own if you'd like, but you'll get the exact same number of 2.8 again. All right, there's number 4.